Good day, everyone. So, in today's class, we are going to be looking at forms of energy. At the end of the lesson, we'll be able to know different forms of energy that we have, as well as the source of this energy we are talking about, and how they are converted from one form to the other. Okay, so let's dive into this. So, first of all, let's start with the mechanical type of energy. Now, previous class, we mentioned that mechanical energy is of two types: the potential energy and the kinetic energy. Now, the potential energy is energy due to position, and it's of two types. We have the elastic potential energy and we have the gravitational energy. While the second one under mechanical energy is called the kinetic energy. This is energy of an object in motion. When an object is moving, we say it is what making use of kinetic energy. Now, we also have what we call the heat energy. Sometimes it is referred to as the thermal energy. This energy is more like internal energy that arises from the motion and vibration of atoms and molecules. So when atoms are vibrating, okay, whenever they are vibrating as they are moving, what they generate is heat. And that's because as they are vibrating, they are colliding with each other. And when they are colliding with each other, there will be friction. And the effect of friction generates heat. That is how heat energy is being generated. Okay. An example is this: the warmth we get from the sun. You begin to feel warm because the atoms in your body receive the direct heat energy from the sunlight, and then the atom in your body begin to collide with each other, and you begin to feel hot. Then we have the chemical energy. These are energy that are stored in bonds between atom and molecules. Okay, so the energy inside the bond that is holding atom and molecule together is referred to as chemical energy. Okay, and we usually absorb this energy through chemical reaction. Right? For example, now the food we eat, okay, is being stored as chemical energy because the the molecule that is holding these food atoms are the ones that that store this chemical in them. We also have them in batteries and the fuel we make use of. The other one is known as the electrical energy. This one is energy that we get as a result of the movement of charged particles. When charged particles are moving, okay, what is generated is called electricity or electrical energy. Now, when they are moving, they either generate um, uh, electricity for the purpose of supplying power, or they might be hazardous. But the point is that when charged particles are moving, and the charged particles are called electrons, then we say that electrical energy is being generated. So this generated energy is now used to power our devices like our phone, our TV, and so on and so on. So we also have other ones like the light energy, which we also call the radiant energy. Okay, this light energy are electromagnetic radiation. Okay, and our human eyes can see it. Okay, for example, the sunlight now. So they are form of energy. Okay, we also have sound energy. As I'm talking right now, I am making sound, and that sound is a form of energy. Okay, and it's produced when there is a disturbance in the air. Okay, when you disturb the air that we breathe in, when you disturb it, then the sound will be produced. Okay, we still have it in a musical instrument. Even a thunderstorm produce sound. They are produced when we vibrate our particles in we vibrate our particles in the air. Okay, then we say we sound is produced. So there must be vibration. When there is no vibration, there can never be sound. And then when this vibration exists, okay, there must be a medium that will transfer this sound. So it's one thing for sound energy to be generated, it's another thing for it to be transported. Okay, By the time you're looking at the sound wave as a topic, you will get to understand it better. But just know that we have sound energy as a form of energy. Then we have the nuclear energy. These are energy that are released during nuclear fission or fission. Okay, and we also use energy to generate electricity as well. Okay, um, then what are the sources of this energy? We have the world energy resources. These world energy resources are divided into two main categories. We have the renewable one, okay, and the non-renewable energy resources. Example of the renewable energy resources are the solar, the wind, the tides, the hydro, the ocean waves. When we say renewable energy resources, they are the energy resources that you cannot exhaust. They are just there. You can never exhaust a renewable energy resource because they keep reproducing by themselves every second. On the other hand, the non-renewable one are the one that after you have exhausted them, it will take a long time before you can get them again. Example of such are petroleum, coal, nuclear, and biomass. So it's important that you understand these two categories so that you know how to manage them, because if you are understanding that non-renewable energy resources will not be available as quick as possible like that of renewable energy, then you will manage how it is being used when it is available. All right. Now let us look at the renewable energy types in detail. We have the solar energy, which is the most common one in our world today. Now everybody is installing solar system in their homes, what some people call inverter. But really, inverter itself is not solar energy itself. Okay, inverter is just a converter. Okay, it converts a DC to AC. Okay, but now I want to talk about solar energy. They are energy that we get from the sun. The word solar actually means energy from the sun. Okay, or sun itself. Okay, so energy we get from the sun is what about solar energy. What happens is that you need a device called solar panel that traps this energy and then convert it to electricity. Then we have the wind energy. The wind energy is also used to generate electric city, city rather. How does it work? When the wind is blowing, okay, you begin to rotate the the wind the wind vane, begin to rotate it. As it's being rotated, it generates heat like that and is being supplied to wherever it's connected to. You have the tidal energy. So tidal energy is like energy from the ocean. So when there is movement of tides, it turns this turbine, and then when this turbine is being turned, mechanically electricity is being generated. Okay. Aside from that, we also have the hydro power and the ocean wave. So just like the tidal energy, this one makes use of water too. When these water are moving, but the hydropower, the energy is obtained from flowing water. Okay, so when this water is flowing, it turns the turbine, and when the turbine is being turned, okay, as you could see it here now, so the turbine will place around this side. As the water is moving, okay, the movement turns the turbine that is around there, and when that turbine begin to turn, it generate electricity. Okay, so on the other hand, the non-renewable energy example, we said these ones when they are exhausted, it takes time before you can use them again. Example of this non-renewable energy resources are petroleum. Okay, petroleum are actually fossil fuel that is obtained from ancient plant and animals. Okay, we also use it to generate electricity. The same thing applies to coal. Coal too is obtained from they are fuel that are obtained from what ancient plants, and they are used to generate electricity. Then we have said earlier, nuclear energy are energy that are obtained from the nucleus of an atom. Okay, we also use to generate electricity. Biomass are organic matter that we get from wood, from crops and waste. These organic matter are also used to generate electricity. But the advantage of this, for example, now when you are going to the forest to cut wood, you know, when you are cutting wood, you are reducing the trees in the wood, in the forest rather. And then as a result of that, it might lead to air pollution because the tree has a way of cleaning the air for us, for us to breathe well. All right. So we mentioned earlier that energy can never be created, nor be destroyed, but can be converted from one form to the other. It is called law of conservation of energy. Okay, energy cannot be created, nor be destroyed, but it can only be changed from one form to the other. So you can change. It can change, for example, now electrical energy to light energy. But there are devices that are doing this. Okay, all right. So we can change from electrical to light. So, for example, now a device that converts electrical energy to light is a bulb. Bulb now, if you connect it to electricity, it gives you light. All right. So we also have the one of potential to kinetic energy. Okay. You can convert energy from potential to kinetic. For example, now as I'm seated talking, I am at my potential energy. If I begin to run now, I will convert energy to kinetic, right? Then the heat to mechanical energy. Okay, this is another way. So each of the conversion makes use of different devices. All right, and they can even be extended more than this. So heat to mechanical energy could be the use of nuclear energy. Okay, nuclear energy generates heat, and this heat energy now is being used to turn the turbine, and then the turbine now supply the electricity. So we can say in this case now that we make use of nuclear. We call it a nuclear reactor, okay, or nuclear generator. Then we have the nuclear to electrical direct. This one is making use of nuclear reactor and then making use of turbine together here. So two devices are combined here. You use the nuclear reactor to convert from heat to mechanical, and then you use turbine to convert from mechanical to electricity. Okay. Now nuclear to electrical, here make use you also make use of these two devices here. That means the nuclear reactor and the turbine. So in essence, each of these conversion makers of device for them to be converted. Okay, for example, now as I'm talking to you, I'm making use of a microphone. Now that microphone is a device that converts what we call sound energy. I'm generating sound. Okay, so you convert that sound energy from my mouth to electrical energy into the system. Okay, and so on and so on like that. So, what is our key takeaway in the lesson of today? First of all, we know that energy comes in different form. We're able to see that we have mechanical energy, which is of two types, either kinetic or potential. And we say potential also is of two types too. That means elastic or the gravitational potential. Then we have the thermal or the heat energy. We have the chemical energy, electrical energy, light energy, sound energy, nuclear energy. Each of these energy plays their unique role in the world that we live. Then we move on to energy resources. We said there are two types, the renewable one, this one that can never be exhausted. Example of such are solar energy, wind energy, hydro, tidal, and so on. On the other hand, we have the non-renewable energy. In this case, you can exhaust them, but when you exhaust them, before you can get them again, it will take a longer time. An example of such are petroleum, coal, nuclear, and biomass. Okay, so we are able to see that it is better to be more careful when using the non-renewable energy so that we don't exhaust them and then be stranded. So we're able to see that energy cannot be destroyed. It's rather converted from one form to the other. That's the law of conservation of energy. That in a closed system, energy can never be created, not be destroyed, but can be converted from one form to the other. All right, having said that, let us see one or two questions on this topic. Here, it said a device that converts sound energy into electrical energy is what? A, the horn of a motor car. The horn of a motor car is not converting sound energy to electrical energy. Rather, it's converting electrical energy to sound because when you press the device, When you press that on, electricity is being supplied to it, and then you hear the sound. So the on of a motor car converts electrical energy to sound energy and not the other way around. Okay, so that is not correct. B, an AC generator. An AC generator, that the generator we use in our various home when there is no light. Now, an AC generator do not convert sound energy to electrical. Rather, it converts mechanical energy. Mechanical energy is when you are drawing the generator, okay, with the air power. So you convert mechanical energy to electrical energy. When you draw your generator with your hand, that's mechanical. Then when you begin to work and supply electricity, that is electrical energy. So AC generator is a device that converts mechanical to electrical. So that's not correct. We are looking for the one that converts sound energy to electrical. And I think I said it in the course of the lesson. So it's a microphone. A microphone is the correct answer because when you make use of a microphone and put it in your mouth, you are generating sound energy. Now the microphone will convert that sound energy to electrical because it will have to enter into the speaker, and the speaker is electrical. So it converts sound energy from your mouth to electrical, and the rest are not correct. So the correct answer is option C. Option D, the telephone earpiece. The earpiece converts electrical energy to sound because the earpiece is like your headphone. Now, when somebody speak into it, that is electrical. Okay. Now you now hear it. You cannot hear it with your ear. That's sound. So that's not correct. It just function like option A, electrical to sound. Okay. Option A and D are the same. They perform the same function. Option E, loudspeaker converts electrical to sound as well. Okay, so the correct option is B. I'm going to explain that in detail so we have an understanding. So let's another question here. Which of the following correctly describe the energy changes in the generation of light by a hydroelectric power station? All right, in hydroelectric power station, it makes use of moving waters. Okay, so first of all, for you to say it is hydroelectric, definitely there will be mechanical stage. The first will be mechanical stage because the movement of the water is mechanical. So just go for the option that start with mechanical. A start with electrical, no. B potential, no. C mechanical. So first stage is mechanical because the water is moving. The next thing is that it will now move the machine, what we call turbine. And as the turbine is being moved, as the turbine is being rotated, it now supply electricity. So mechanical to electrical. Okay? Mechanical to electrical, then light. So the correct option is D. We go with kinetic. Okay, that the water is moving, to mechanical because it will turn the turbine, and electrical because there will be generation of electricity which will now be be converted to light using the bulb. So the correct option is D actually because mechanical fire will have been the one, but since kinetic is involved, kinetic is much more clearer because you have to involve movement. So kinetic and mechanical are similar in nature. It's just that this one deals with the movement of the water, while this one deals with the rotation of the turbine. So correct option is D. Okay. Let's see this other question. Say a cone in an unstable equilibrium has its potential energy A decreased, B increased, C unchanged, D oscillating. When does a cone when is a cone in unstable equilibrium? That's the question we should be asking ourselves. Now, this is very, very straightforward. So let me draw a cone in the unstable equilibrium. When a cone is unstable equilibrium, this is how it looks like. It means that the tip, the vertex is the one on the ground like this. This is a cone. Okay. So this is a cone. Now this is the vertex here. Whenever it's standing with its vertex on the ground, that means unstable. Obviously, this cone will definitely fall down because this vertex is not having a wider base. Okay, unlike the base here. When it is in this form, then you say it is unstable. And when it is unstable, definitely the potential energy will also decrease, because if this is the height before, potential energy deal with height. If this is the height before, and then because it's unstable, it will definitely fall and then be lying in this in this in this form. So if it is not lying down, then the height will be reduced. So definitely it will decrease. The the potential energy what will decrease because the height has been reduced. All right. And lastly, let's consider this other question here. It says here that the energy in the nucleus of an atom produce heat, which can be used to generate electricity. Of course, we have talked about that one on nuclear reactors. So the energy that we get from nucleus of an atom is referred to as uh, nuclear energy, and they can be used to generate heat. And this heat is used to produce electricity. All right. Okay, so we are going to be drawing the curtain here. I hope you have learned something into this class. Thank you for listening. Have a wonderful day. Bye for now.